Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So in the photoelectric effect experiment, we know that the energy of the photon is used up by the electron to overcome the work function of the metal or the surface that we're looking at, and the remaining energy goes into the kinetic energy of our electron. And this kinetic energy can be obtained by looking at what is the potential that would stop these electrons from reaching the other side, right? So this is related to the stopping potential via Q times the stopping potential, where Q is the charge of our electron. So in this case, it's just EV. We are given that the potential in this case is 2.1 volts, and so the kinetic energy is basically 2.1 EV. The photon energy we are using for the first part is 290 nanometers wavelength, so that's Hc over 290 nanometers. We're going to use Hc to be 1.24 times 10 power of 3 EV dot nanometers, so that we can get the energy in terms of EV. And from here we can find what is the work function of the metal. Right, so you just have to rearrange this a bit. Get 1.24. Right, so this is the work function, which is about 2.176 EV. Next, we are given that we change the light, right? The energy of the photon is now, we are using a 440 nanometer light. So with a 440 nanometer, the energy of the photon, I think is C over 440. Right, so this is the energy of the photon. We equate this to the work function plus the remaining kinetic energy in the electron. So since we know the work function is 2.176 kinetic energy, just take this value minus 2.176, 0.64 EV. Right, this is the kinetic energy, and therefore the voltage required, right, the stopping potential required to remove this kinetic energy is just kinetic energy divided by E, which is 0.64 volts.